In this video, we will learn how to use StatCrunch to do hypothesis tests for a mean. So just like for confidence intervals, the data can be presented either as summary data or actually as a data set. So first we're going to use summary data. In 2001, the mean household expenditure for energy was $1,493, according to data from the U.S. Energy Information Administration. An economist wanted to know whether the amount had changed significantly from its 2001 level. In a random sample of 35 households, she found the mean expenditure in 2001 dollars for energy during the most recent year was $1,618, with a standard deviation of $321. Has the mean household expenditure for energy changed? We want to first write the null and alternative hypotheses. So we notice that the question here is, has the mean changed? And when we do that, what are we going to do for our alternative? We're just going to say a not equal to. So the mean here is going to be mean equal to where it was originally, which was $1,493. And our alternative is going to be that the mean is not equal to $1,493 because the economist didn't have a feeling as whether it would go up or down. Now we want to do the hypothesis test. Now remember, we're going to be using a t-statistic this time because we don't know the population standard deviation. We're using the sample data to estimate it. So in StatCrunch, we're going to go to t-stats, one sample with summary, which means we have to enter in the mean from the sample, which was $1,618, and the standard deviation was $321, and the sample included 35 households. And then we're going to put in our null here, was the mean equal to 1493, and our alternative is not equal to, and we'll hit compute. And so we see here the test statistic is right here, 2.30. So I'm going to go ahead and write that over here. So it's a t, and it's equal to 2.30. And the p-value here is 0.0275. And we were testing at 0.05, so we would reject because our p-value is less than the alpha level. And so what we can say is that yes, the mean expenditure for energy has changed from the 2001 level of $1,493. Now, we also want to go and do a problem where we have the data. And so in this question here, we have a certain brand of apple juice is supposed to have 64 ounces of juice. Because the penalty for underfilling is severe, the target mean amount of the juice is actually increased a little bit to be 64.05 ounces. However, the filling machine is not precise and the exact amount of juice varies from bottle to bottle. The quality control manager wishes to verify that the mean amount of juice in each bottle is 64.05 ounces, so she can be sure that the machine is not over or under filling. She randomly samples 22 bottles, measures the contents, and gets the data that's shown below. And I went ahead and I put this into a StatCrunch worksheet. And we're going to go ahead and first we want to write our hypotheses again. So what are we going to test here? Our null is going to be that the mean is equal to a target of 64.05 ounces. And again, we're going to do a not equal to because we don't have an idea that it's going to go higher or lower. She just thought she wants to make sure it's not over or under filling. So we're going to say the mean is not equal to 64.05 ounces. And we're going to go ahead now in StatCrunch. I'm going to go to Stat, also T-Stats, again, one sample, but this time I have the data. So when I have the data, I don't have to enter the mean, standard deviation, and sample size because StatCrunch will calculate that for me. I'm going to go down here and I'm going to put in that 64.05, and my alternative again is not equal to, compute. And so I see here my test statistic, and notice that the mean from the sample is just at 64 ounces. So it's below the target. So our test statistic here, again, it's a t, and we've got negative 4.49, and the p-value is pretty small. So it's 0.0002, which is definitely less than 0.01, and so we're going to reject this time. And we're going to say that we have evidence that it's not meeting the target fill of 64.05 ounces. Now, it would be interesting, just while we're here, to just go back in and edit this for a second. And let's go ahead and do the confidence interval and maybe do a 95%. And we notice when we do that, this confidence interval goes from about 64 ounces up to 64 64.03 ounces, which is below that target of 64.05, which confirms our decision to reject the null hypothesis.